Dear students, welcome and thank you for tuning in to this video. I'm Dr. Layal Zorbi. We are continuing a series of videos about linear kinetics of human movement as part of the biomechanics class. In this video, I will continue my discussion about Newton's laws of motion, and I will be talking about Newton's third law, the law of reaction, which is one of the important laws in biomechanics and in exercise sciences. So what is the law of reaction? We know that for every action, there is an equal and opposite reaction. So when a body exerts a force on a second, the second body exerts a reaction force that is equal in magnitude and opposite in direction. An example of that from our physics basic knowledge is Newton's cradle. If you look at the image to the right bottom of the screen, you can see Newton's cradle. If you lift one of these metal balls up, let's say the one to the right, you are giving it potential energy, and if you release that ball, the potential energy will be transferred into kinetic energy. And the ball hit the other one next to it, this ball is going to transfer the energy stored in it to the next ball, and then that one will transfer it to the next one and to the next one till to the last one to the left, where if we don't have any friction and if we are assuming we have a perfect elastic collision, the entire energy will be transferred to the ball to the left and it will move up the same height the first one was moved to the right. And that is actually the law of reaction, because for each action there is a reaction equal in magnitude and opposite in direction, and that's the Newton's cradle is an example of this law. Now in biomechanics, so how are we using it, and what kind of applications we can use the law of reaction in? I'm going to show you this example, and in biomechanics lab, we have a force plate. One of the examples, the AMTI force plate. This force plate is a device that allows us to measure ground reaction forces. And what we mean by that, so if someone is walking on the ground, because of your weight, of the subject weight and muscle strength, we are pushing on the ground. At the same time, the ground is going to push back with the same amount of force and in an opposite direction according to Newton's law of reaction. And what we are seeing in the figure, in the image, in the figure in this image, we are looking at what is the ground reaction force. So this is how much force the ground is pushing back on the subject in return of the weight of the subject and the forces of the muscle. And these patterns that we're looking at, those are the forces in the z direction, the perpendicular direction. And we can measure, for example, in this example, we are measuring the force exerted by a striker when they are, walking or running on the force plate. If they are doing rear foot strikes, or if they are doing middle foot striker. So you look at two different strikers. One of them is you're doing a rear foot strike, and the other one is doing a midfoot strike. And you can see the difference in the patterns. So the solid line actually is the rear foot striker, forces, and the dashed line is the midfoot striker. We know from biomechanics and exercise sciences that a rear foot strike is not a healthy choice, and then you can compare between the two subjects. And if someone is doing that, you can tell them that they're doing something wrong. And that's a very good application and a simple application of the law of reaction in biomechanics. And one of the things that we do actually in our biomechanics lab is that we can assess, athletes' performances or people with disability or people with injury performance using such devices. So the Newton's law of reaction is a very important in biomechanics. Also, we can look at another application, and we can measure that in accordance with the Newton's third law of motion, which is the law of reaction. Ground reaction forces are sustained with every footfall during running. And because we are pushing on the ground is going to push back on us. And that because of each force, for each action there is a reaction equal in magnitude and opposite in direction. Now athletes use this to improve their performances in such a way that sprinters are able to generate forward directed horizontal component of the force of the reaction force of the ground, so that it helped them move forward faster. And this is another application and use of biomechanics in exercise sciences and also by athletes. And this is another example of how important understanding the law of reaction for all performers or athletes. I would like to go into an example from biomechanics and to, it's a quick quiz to test our understanding of the concept. So if we say there's a high jumper with a body weight of 712 newtons, exert a force of 3 kilonewtons against the ground during takeoff, how much force does the ground exert on the high jumper? And if your answer was 3 kilonewtons, that is correct. And the reason why we're not using the weight of the subject is that remember we are using Newton's third law and the law of reaction. So for each action there's a reaction. So if the subject is exerting 3 kilonewtons against the ground is going to push back and exert 3 kilonewtons on the subject. I hope that was a clear explanation and with examples and applications in biomechanics for the law of reaction. Thank you for watching. Until the next video. Bye.